This video is going to cover limits, the laws, and finding limits algebraically. So up here are just very basic limit ideas here. So if you find the limit of just a constant function, well, it is that constant function. That's just a horizontal line. And if you're finding the limit of just an x value, it is just that whatever value you're trying to find the limit of. And with these guys, if you know how to sketch these, that really helps. So this 1 over x looks like this, with the asymptote going each way. So knowing that little sketch there, what 1 over x looks like, it really will help you with your understanding for these. Now the laws that are a little bit more complex, but really not so much, are the ones we're going to focus on right here with all of these. So we gotta let the limit as x approaches a of a function equal some answer, and the limit of g of x as you approach a of g of x also has to be another answer. And then if that's the case, if you add two limits, it can be just written out as just adding the two limits. So that's why you get an answer right here. So your answer is addition. Same thing with subtraction. Subtracting two limit values that exist, your answer is going to be the subtraction of those limits. That's important. These have to exist. Multiplying as well works out. Dividing works out, provided that that bottom one does not equal 0. It also works out for square roots as well. Okay, and again, these are all provided that the limits exist. If you're ever a little confused about this, you're like, I don't know if it works or it doesn't work, well, just find the limits from the right and from the left, and then that will help you out tremendously. Alright, so let's go ahead and use the limit laws for this example right here. So what we got here is we're going to write this out as the limit as x approaches 5 of x squared minus 4 times the limit as x approaches 5 of x plus the limit as x approaches 5 of 3. So you're just going to do each one of these separately. So for this, for x squared, we're just going to just plug in that 5 value. So plug in a 5, we're going to get 5 squared minus, plug in that 5 right there, the 4 stays in the front, we're just multiplying, so 4 times 5, plus the limit of any constant is just whatever that constant value is. There's no x value to plug into. And when you get this, you're going to get an answer of 8. So that's just one way you can use the limit law. Alright, now finding the, actually, I forgot to talk about the bottom. My bad, super important. Take note that the limit of the denominator is 0, then the limit of the numerator is not. Then the limit can be positive infinity, it can be negative infinity, or it can be negative from one side, positive from the other. What that really is trying to say that is if I have a limit as x approaches 4 of like 1 over x minus 4, if I just plug in right away, I would get 1 over 0, which is a big no-no because we cannot have the denominator be a 0. So that's a big old no-no. So then your answer is going to be one of these choices: negative infinity, positive infinity, or if the sides don't match, the other option is it would not exist. Alright, but we will get into that in an example on the next page here. So, alright, this is how it's going to work for limits algebraically. You just plug in directly. Okay? If you ever get 0 over 0, then you need to do some type of fancy math trick, which you should already know all these fancy math tricks already. I'll just kind of guide you there. So for this first one, if I plug in a 2, the top is going to give me 2 squared minus 4, which is 0. If I plug in a 2 on the bottom, I get 2 minus 2, which is 0. So this is going to give me a 0 over 0. I can't have that. Now please take note of what I'm going to do in the red. I never write that this is equal to 0 over 0. Because with that equal sign, you're trying to tell me, the grader, that, oh, this limit value is equal to 0 over 0. But that's not true. It is not equal to 0 over 0 because we have to do some math. So I'm going to put a big old don't do this. Okay? So the first trick I'm going to teach you here is just to factor and simplify. Because whenever you get 0 over 0, that means that we have a whole. Okay? So the best way to find out the value of a whole is to factor and cancel. So the top does factor very nicely. It factors into x plus 2 and x minus 2. Bottom stays the same. Whenever you show work, you must show your limit as well. You don't get lazy and just write down the function. You have to show the limit value as well. Okay? So now what's nice here is we're going to get these two values to cancel out. So we're going to get the limit as x approaches 2 of x plus 2. Now we're ready to plug in. When we plug in, we're going to get 2 plus 2, which is 4. So the first fancy trick you're going to learn about limits here is factoring and canceling. The next one is going to be a little bit similar, but we're actually not going to be able to factor it. Well, I don't want to say you can't factor it, we'll just look at it a little different approach here. So with this, if I were to plug in a 1, I'm going to get 0 on the top, 0 on the bottom, which means I'm going to have a hole somewhere, so I need to do a little bit of a trick. Here's a trick for this one. Whenever you have a square root, you're going to multiply by the conjugate. Okay, so I'm going to multiply the top by the conjugate. When I do that, I'm going to get the limits as x approaches 1. I'm not going to distribute. If you do that, you're going to have to factor again, and it's not a lot of fun. On the bottom, since I'm multiplying by the conjugate, now I don't care if the conjugate is not always the bottom, it's just wherever the square root is. That's where you multiply the conjugate. Conjugate, again, means different sign in between the two terms. So when I do that, I'm going to get x minus 1. Okay. So what's really nice with this is, after I multiplied that little green part, I'll put the times sign there, I'm going to get something to cancel. X minus 1s are going to cancel. And now I just have the limit as x approaches 1 of root x plus 1, which means I'm now ready to plug in that 1 value. So when I do that, I'm going to get 1 plus 1, which is 2. These are just two examples of many different ways to do these types of problems. So factoring, conjugate, really you're just going to just keep using math skills that you learn. Keep going until something cancels and you're able to plug in your value. Now, piecewise functions. Piecewise functions are the functions that have different pieces to it. So one way to do it is you can go ahead and find the one-sided limits whenever you do piecewise functions, and then another way is to go ahead and graph it. Okay? So I'm actually going to do this one right here, and the graphing one you can try on your own. Okay? So when you find the one-sided limits, I'm trying to find the limit here as x approaches negative 2. So I need to find the limit as x approaches negative 2 from the left first of f of x. I'm going to find that value. So my piecewise function, we're looking at negative 2, and this is when x is less than negative 2, so this is the left value. So this is going to be equal to the limit as x approaches negative 2. So again, I'm using this part of the piece over x plus 2. So what happens now is when I plug this in directly, I'm going to get 1 over 0. Again, I talked about this on the last page. You can't get something over 0. So this means that we're going to have to investigate. Okay, so let's go ahead and investigate this now. What do we mean by that is we want to find if this is going to positive infinity or if it's going to negative infinity. So the best way to do that is to pick a number that's really close to -2 from the left. So I'm going to pick a -2.1. You don't need to go too fancy here. So if I pick an x equals -2.1, I'm going to get 1 over -2.1 plus 2, and that's going to equal a positive over a negative. Again, I don't care about the exact value. So if I have a positive divided by a negative, that's going to give me a negative value. So this is equal to negative infinity. Okay, again, different signs between negative infinity. So this is from the left. I now need to find the right value. And if they match, it's awesome. My answer would be negative infinity because they would match. If they don't match, then my answer does not exist. So I'm going to do -2 from the right. So looking at this piecewise function, from the right is going to be this little guy right here. So I'm going to do the limit. X approaches -2 from the right of x squared minus 5. And when I plug this in right away, I'm going to get -2 squared minus 5, which is going to end me up with a -1. These do not match, so the path from the left is negative infinity, path from the right is -1, so therefore limit x approaches -2 of this function does not exist. Again, you can graph it as well and look at it, and I'll leave that up to you for practice. And that concludes our video.